Hello everybody, welcome to the course on discrete mathematical structures. In this today's session, we are going to discuss the fundamental principle of counting that comes in module 2 of your syllabus. Fundamental principle of counting, in that we have two rules. One is the rule of sum, another one is the rule of product. What is rule of sum? The rule of sum states that suppose if we have two tasks T1 and T2, assume that T1 can be performed in m different ways. The task T2 can be performed in n different ways. And if these two tasks cannot be performed simultaneously, that means if task T1 is happening, T2 cannot happen. If task T2 is happening, T1 cannot happen. Then one of the tasks T1 or T2 can be performed in totally m plus n ways. Suppose if you have, let's take an example. Suppose I want to select a class representative for a class which has 20 boys and 30 girls, then suppose if I want to select either a boy or a girl, I can't select both boy and the girl. If I want to select either a boy or girl, since there are 20 boys and 30 girls, the total number of ways of selecting either a boy or a girl is 50 ways. Okay. Consider one more example. Suppose a library has 12 books on maths, 10 books on physics, 16 books on computers. In how many ways a student can choose one of these books for study? This can be given by, see, if I want to study, a student can study books on maths or books on physics or books on computers. The total number of ways of performing this activity is, he can read 10 books on physics, that's why the total number of years are 10. Since he can read 12 books on any one of the book on any one of the 12 books in maths, that's why total number of years are 12. Similarly, he can read any one of the 16 books on computers, that's why the total number of years is 16. Either he has to read the physics or the maths or the computers. The total number of ways of performing this activity is equal to 38 ways. This rule is the rule of sum. See, one more rule is there is the product rule. It states that suppose as usual, if you have two tasks T1 and T2, T1 can be performed in task T1 can be performed in m different ways. Task T2 can be performed in n different ways. Then, and for each of these ways, see, suppose you have two tasks T1 and T2, such that T1 can be performed in m different ways. And for each of these ways, T2 can be performed in n different ways. And both the tasks are performed simultaneously. That means one after the another, both are dependent. The total number of ways of performing the tasks is m into n ways. Always rule of product means multiplication, rule of sum means addition. See, consider an example to illustrate this. Suppose a person has 8 shirts and 5 ties. Then the number of ways of choosing a shirt and a tie is, see, a person has to suppose person has 8 shirt means S1, S2, S3, S4, S5, S6, S7, and S8. Similarly, 5 ties means T1, T2, T3, T4, T5. Suppose if he has chosen S1, then he can choose T1 or T2 or T3 or T4 or T5. Similarly, after choosing S2, he can choose T1, T2, T3, T4, T5. Similarly, the total number of ways of performing this activity is 8 into 5, because after wearing the shirt, compulsorily he has to wear the ties, because there is an and here, the keyword and here, and is always the multiplication. This rule is called as the rule of product. Here both are dependent. First he has to wear the shirt, then compulsorily he has to wear the tie. But in the previous rule of sum, both are independent events. Let us see some examples to illustrate the rule of sum and the rule of product. Cars of a particular company come in 4 models, 12 colors and 3 engine sizes and 2 transmission types. How many distinct cars of this company can be manufactured? Of these, how many have same color? See, you take a company which comes in 4 models, which has 4 models, then 12 colors and 3 engine sizes and 2 transmission types. Then how many different models we can manufacture? See, the first activity can be performed in four ways. Second activity can be performed in 12 ways. Third activity in 3 ways, and the fourth activity in what? The 2 ways. That means if I want to manufacture a car, see the first sub question: how many distinct cars of this company can be manufactured? If I want to manufacture a car, you should I can have 4 models, 12 colors, 3 engine size, and 2 transmissions. All the things has to be happen simultaneously, one after the another. That's why the number of distinct cars that can be manufactured with the 4 color models and 12 colors and 3 engine sizes and 2 transmission type is 288. This is since we need to apply the rule of product here, because a car means it should be a different model, color, and the size. Since all are dependent events, that's why we are going to use what? And all are happening simultaneously, one after the another. That's why we are going to use the rule of product. Star means the multiplication. Then the second sub question is, of these, how many have the same color? See, of keeping the color as the constant, out of, suppose you have 12 colors, out of this you keep color as the constant. For a chosen color, the number of distinct cars that can be manufactured is 4 models into 3 engine sizes into 2 transmission types, that is equal to 24 ways. Here we are, suppose if I have one color, you take any one color. After choosing the color, the different models which we can manufacture is, after choosing the color, the different models which we can manufacture is, the different cars we can manufacture is with 4 models, then 3 engine sizes and 2 transmission type. Suppose you have 12 colors, color 1 with the 24 ways, similarly color 2 with the 24 ways, then color 3 like that, color 12 with the 24 ways, thereby keeping color as the constant. Okay. Next, consider one more question. A bit is either a 0 or 1. All of you are very familiar with the bit, since being a computer science student. All of you know what I mean by bit. A byte is a sequence of 8 bits. Find the number of bytes. Next, second sub question: number of bytes that begin with 11 and end with 11. And the third sub question is the number of bytes that begin with 11 and do not end with 11. The fourth sub question is the number of bytes that begin with 11 or end with 11. See, a bit is a binary digit. It can have either 0 or 1, which is the unit of information in a computer. Computer stores all the information in the form of zeros or ones. Okay. Since a byte has 8 bits, since we have 8 locations, in each location either I can fill 0 or 1. That means in each location I have 2 choices. Therefore, the number of bytes, suppose in the first location, either I can place 0 or 1. In the second location, 0 or 1. Third location, I can place 0 or 1. Like that, in all the locations, 8 locations, I can place 0 or 1. That means in each of the location, I can place 0 or 1 means for me 2 choices are available, 2. Since there are 8 locations, 2 into 2 into 2, that will be repeated 8 times. That's why 2 to the power of 8 is 256. Okay. Now next move on to the second sub question. Number of bytes that begin with 11 and end with 11. Number of bytes that begin with 11 means out of 8 bits, the first 2 bits are fixed and the last 2 bits are fixed. That is the remaining 4 empty locations. That means suppose you have 8 locations. Out of that, first 2 are fixed, that is 11, beginning with 11. The last 2 are also fixed, that is ending with 11. The remaining 4 empty positions, there is in each 4 positions, I can place either 0 1, 0 or 1, 0 or 1, or 0 1. That's why total number of ways of placing the remaining 4 vacant positions is 2 to the power of 4 is 16. Therefore, there are 16 bytes which begin and end with 11. Then the next sub question is the number of bytes that begin with 11 and do not end with 11. See, in a byte beginning with 11, there are 60 empty positions, 6 empty positions. Suppose since we have 8 locations, out of that, the first 2 bits are fixed, that is beginning with 11. The remaining 6 empty positions can be filled in. Each empty position occupies, it can take either 0 or 1. That means 2 options, 2 choices for me. This has to be repeated for 6 empty positions. That's why 2 to the power of 6 is 64 ways. Thus, there are 64 bytes that beginning with 11. Now, since there are 16 bytes that beginning with 11, since there are 16 bytes that begin and end with 11, the number of bytes that begin with n1 11 but do not end with 11 is obtained by subtracting the number of bytes that begin with 11 minus the number of bytes that end with 11. What is the number of bytes that end with 11? That is 16. 64 minus 16 is 48 ways. This is the answer for the third sub question. Next, we move on to the fourth question. The number of bytes that begin with 11 or end with 11. See, the number of bytes that begin with 11 is 64. The number of bytes that begin with 11 is 64 because the first 2 bits are fixed. The remaining bits, 6 bits, can be placed in how many ways? 2 to the power of 6, 64. Also, the number of bytes that begin and end with 11. The number of bytes begin and end with 11 is 16 because first 2 and last 2 bits are fixed. That's why number of bytes begin, then the remaining options available for me is 2 to the power of 4 is 16. Therefore, the number of bytes begin or end with 11 is the 64 plus beginning with 11 or 64 minus 16, that is equal to 112 ways. That is the total number of ways. Next, we move on to one more question. Find the number of proper divisors of the following number. What is the number? The number says 44,01,000. See, whenever I want to say a proper divisor, any number is a proper divisor. It is divisible by any other number other than 1 and itself. That means, for example, if I take the number 4, the proper divisors of 4 are 1. The divisors of 4 are 1, 2, and 4. Out of that, the proper divisors of 4 are 2 only because we need to exclude 1 and 4. Okay, and the similar lines, we need to find out the proper divisors for 44,01,000. How to find out that? Let us simplify this number by using the prime factorization method. Then you are going to get 2 to the power of 3 into 3 square into 5 cube into 7 square. Therefore, every divisor of n 44,01,000 must be of the form 2 to the power of p, 3 to the power of q, 5 to the power of r into 7 to the power of s. That means Your P can assume the value from 0 to 3. Similarly, Q can assume the value from 0 to 2. Then the value R ranges between 0 to 3. Then similarly, the value S ranges between 0 to 2. Therefore, this P can be chosen in 4 ways, Q can be chosen in 3 ways, R in 4 ways, and S in 3 ways. Therefore, the total number of divisors is equal to the number of ways of choosing P as well as number of ways of choosing Q, number of ways of choosing R, and the number of ways of choosing S. That is 4 into 3 into 4 into 3, that is equal to 144. But as I already mentioned, the proper divisor means we need to exclude 1 and itself. This 1 and 44 lakhs 1000. That's why 144 minus 2 is 142. There are totally 142 divisors, proper divisors of 44 lakh 1000. See the next we move on to the one more question. Determine the number of 6-digit integers. Determine the number of 6-digit integers, no leading zeros, in which the first sub question is no digit is repeated. Then the second sub question is no digit is repeated and it is even. Then the third sub question is no digit is repeated and it is divisible by 5. We need to form the 6-digit number. But in the first place, 0 should not happen. Then let us answer the first sub question. No digit is repeated. See, since we have 6 positions to be filled, the first position need not to start with 0 here. See, if I say 6-digit number, see, number means we can form the number by using the digits from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 8, 9. There are totally 10 digits. Okay. Out of that, we have 6 positions to be filled because 6-digit integer. The first position can be filled excluding 0. That means except 0, the remaining digits are from what? 1 to 9. That's why it can be filled in 9 ways. Having filled any one of the number from 1 to 9, that is one of the digit is occupied, then the second position can be filled in 9 ways. Here we are going to include 0 also, excluding the first place digit. Suppose here 1 is occupied, means we need to select any of the digits from 2 to 8, including 0. That's why total number of digits are 9. Then the next positions can be filled in 8 ways, because having filled the first position and the second position, the remaining digits are 8. The next position can be filled in 7, because the first 3 positions are filled by 9, 9 and 8. Okay. Then the remaining ways are 6. Then the next position can be filled in 6 ways. And the next position can be filled in 5 ways. The total number of ways of doing this such that no digit is repeated without leading 0 is 1,36,080 ways. This is the answer for the first sub question. Now next move on to the second question. No digit is repeated and it is even. If you want to say it's an even number, there are 2 possibilities. The number has to end with 0. Any number is an even number if it is ending with 0 or 2 or 4 or 6 or 8. That's why we can split this problem into 2 cases. The first case, suppose if the last unit place is 0, then the case 2 is if the unit place is not 0. Let us split the problem into 2 cases. There are 2 possibilities. If you want to check it's an even number, it has to end with 0 or it has to end with either 2, 4, 6 or 8. If the unit place is 0, the one way of selecting the unit place as 0 is one way. Since 0 is fixed here, then since we need to form the 6-digit number, we need to fill the 6 positions here. The first position can be filled in 9 different ways, excluding 0 here. because the 0 is fixed here. The 0 can be fixed in what? 0 can be placed in how many ways? One way in the unit place. Having filled 0 here, the remaining 9 digits can be placed in 9 ways. Similarly, if I want to fill the second portion, having filled the first place and after filling the unit place, there is 0, the remaining digits, suppose you have selected 1 here and here you have selected 0, then the remaining digits are how much? 8 here. In this, these 8 digits can be filled in 8 ways. Having filled the first place and the second place as well as the unit place, the next place can be filled in 7 ways. Similarly, the next place can be filled in 6 ways. The next place can be filled in 5 ways. Finally, let us assume this value as S1. In the next case, in the first case, we assume that the unit place is 0. In the second place, we assume that the unit place is not 0. That is, unit place can take either 2, 4, 6 or 8. That means unit place will have 4 choices. Either I can place 2 here or 4 here, 6 here or 8 here. Totally how many choices? 8 possibilities, 8 locations I need to fill. Having filled the unit place, since the 0 should not appear in the beginning of the number, 6-digit integer, the remaining options available for me is, the remaining options available for the first place is 8, because here since I should not start with 0, the remaining digits are 8, the remaining digits are 9. Out of the 9 digits, suppose 2 is occupied, any one of the even digit is occupied, the remaining digits left out is, here 0 can be added here. Here 0 can be added. This way the second position can be filled in 8 ways. Having filled the first place and the second position as well as the unit place, then the next digit can be placed in 7 ways, 6 ways and the 5 ways. Let us call this as S2. Either the number has to end with 0 or it may not end with 0. There are two possibilities. Either it may end with 0 or it may not end with 0. That is, it can take either 2, 4, 6 or 8. This can be performed by using the rule of sum. The first task can be performed in S1 ways. Second task can be performed in S2 ways. Both are independent. That's why the total number of ways of performing the task in S1 ways is 15,120. Then the in S2 ways is 53,760. The total number of ways of performing a 6-digit number such that no digit is repeated and it is even is 6,88,080. Okay. Then let's move on to the last question. No digit is repeated and it is divisible by 5. See, if it is divisible by 5 means the number has to end with 0 or do not end with 0. If any number is divisible by 5, if it is ending with 0 or ending with 5. That's why you can split this problem once again in two cases. Suppose the unit place is 0. Then one more case is unit place is not 0. The unit place is 0. Having filled the unit place, since I need to form the 6 digits, we need to fill up the 6 positions here. Having filled the unit place, that is 0, it can be done in one way. The remaining digits from 1 to 9 can be filled in 9 different ways in the first position. Having filled the unit place and the first position, the remaining digits are 8. That means we can perform in 8 different ways. Having filled the first position and the second position and the unit position, that is fixed, that is 0. The next position can be filled in 7 ways. Similarly, 6 ways. The next one is the 5 ways. Suppose the unit place is not 0. That means suppose the unit place is exactly 5. Then this can be done in how many ways? The 5 ways. Since one of the digits 5 is fixed here from 0 to 9, probably we have 10 digits. Okay. Out of that, one of the unit place is fixed here. Having filled the unit place, the first position can be filled in 8 different ways because here no leading zeros. Zero should not appear here. Zero should not appear means if zero is gone as well as the 5 is gone, then the remaining digits left out for me is 8. Having filled the first position and the unit place, okay, the next position can be filled in 8 ways because here 0 is added. Here 0 is added. The next, having filled the first place, second place, and the unit place, the next position can be filled in 7 ways. The next position can be filled in 6 ways. The next immediate position can be filled in 5 ways. All things has to be happened because if I want to form a 6-digit number, all the positions has to be filled. That's why we are going to use the rule of product here. But the final problem says if I want to say that the number is divisible by 5, either it has to be end with 0 or it has to be divisible by 5. That's why the unit place is 0, the number of ways of performing this is 3. And the next one is if the unit place is not 0, then the number of ways of doing this one is 4. Upon simplification, then you are going to get 15,120, then 13,440. The number of ways of forming a 6-digit number with no leading zero such that no digit is repeated and it is divisible by 5 is exactly equal to 28,650. This is the final answer for the last sub question.